Dear friends, in last video we have seen how Excel is used to check the significance of difference between two uncorrelated means. Now in this video we will see how Excel can be used to check the significance of difference between two correlated means. Friends, two situations are given here in which two means are considered as correlated means. Situation number 1, pre-test and post-test. When pre-test and post-test scores are there and the means obtained from the scores of both the tests are to be compared, then such two means are said to be correlated. Generally it happens in experimental design. Here in shown on the screen in bracket, T1 is pre-test, X is some treatment and T2 is post-test. Another situation is two groups are made by matching pair method. When two groups are made by matching pair sampling method, then the means obtained from the scores of both the groups will be considered as correlated means. In these two situations, T value is calculated in the same manner in Excel. How? Let us take one example. One example is given here in which the pre-test and post-test scores of government employees of Mathura are given to check the significance of difference between two means. The hypothesis is formulated as shown on the screen. There is no significant difference between mean scores of government employees of Mathura in pre and post test of communication skill. Now to check the significance, to find T value, we transfer these data in Excel sheet. As shown on the screen, here in an Excel sheet, pre-test scores are entered in column B and post-test scores are entered in column C. The range of pre-test scores is B2 to B13. So from cell number B2 to B13, the scores of pre-test are entered. In the same way, the range of post-test scores is C2 to C13. Okay. Now we find N1, number of observations in pre-test. So to find it, we write equal sign count bracket and data range, that is B2 to B13. Number of observations in pre-test is 12 and number of observations in post-test, that is N2, will be counted in the same way. For that, we'll start with equal sign, then we'll write count and data range C2 to C13, then bracket over and enter key. This is also 12. Now we'll find DF. The formula of DF is given N1 minus 1. Friends, remember, when two correlated means are given, then DF is found by using this formula N1 minus 1 or N2 minus 1, because in both the groups the number of observations will be always equal, because here we have to find R also. If we are doing manually, if we are finding T value manually, then we need R also. Now we find DF N1 minus 1 or N2 minus 1. N1 is calculated in G1. So to find DF, we write here equal sign, then G1. G1 is the cell address where N1 is counted minus 1. So DF is 11. Now we find P value, probability value. This value shows that the means are significant at this particular probability level. How to find it? For that, first we write equal sign, then we write t-test then the data range of first data, that is B2 to B13. Then we put comma. B2 to B13 is the range of first data set, that is pre-test course. After putting comma, we'll write the range of second data set, that is the range of post-test course, and it is from C2 to C13. Then we put comma. After comma, we have to write here 1 or 2. 1 for one-tail test and 2 for two-tail test. We are going to check null hypothesis, so it will be two-tail test. So we'll write here after comma 2. Then we have to write here 1, 2 or 3. When 3 is written, that we have seen in previous video, here we will write 1. When 2 correlated means are there, then at last after comma we have to write 1 and then close the bracket and press enter key. This is probability. It means the difference between the means of pre-test scores and post-test scores is significant at 0.054 level. On the basis of how to interpret these all things that we'll see later, now we'll find t-value, and t-value is found on the basis of probability value. For that, the function is equal sign, it starts with equal sign, then we have to write t inv. Inv means inverse, and then bracket, and then we have to write the probability value, but probability value we have already found, and it is found in F6. Probability value we have found in F6, so we'll write here F6. Then we put comma. After probability value, we have to put comma, and after comma we have to write DF. DF we have counted here 11, so we'll write here 11 and then bracket over and press enter key. So t value is there. Friends, hypothesis can be checked by using probability value or t value. How it happens, let us see. For that, we take entire results and try to understand how the hypothesis is checked on the basis of p-value and t-value. Here p-value and t-value are given, probability values and t-values are given. First we see how probability values value is used to check the hypothesis. For that, 3 normal rules we have to remember. If 0.01 is less than p is less than 0.05, hypothesis is rejected at 0.05 level of significance. It means if probability value is between 0.01 and 0.05, then hypothesis will be rejected at 0.05 level of significance. Rule number 2, if p is smaller than 0.01, then hypothesis is rejected at 0.01 level of significance. And our probability value is 0.0543, that is greater than 0.05 and greater than 0.01. Now see third rule. Third rule is if p is greater than 0.05, hypothesis is not rejected. See, our probability value is 0.0543, that is greater than 0.05. So hypothesis will not be rejected, and in the column of significance we will write there not significant, NS. We have written here NS, it is not significant. The difference is not significant. Friends, here we have seen that how probability is used to check the hypothesis. Calculated probability, that is calculated with the help of Excel. Now we will see how on the basis of t value we check the hypothesis. Here t value is already calculated and it is 2.1534. If t value is there, then we need df, that we have already calculated, and it is 11. If T value is there and DF is there, then we have to refer T table. In T table, in the column of DF, we have to locate our DF. Our DF is 11. So in the line of 11, we have to see the value written under the probability 0.05 and under probability 0.01. Under probability 0.05, for DF 11, the required minimum value for significance of difference is 2.2 and required minimum value for significance at 0.01 level is 3.11. These two values we have to remember, and we have to compare our calculated T value with these two values. At 0.05 it is 2.2 and at 0.01 it is 3.11. Now T table value that we have seen, at 0.05 level it is 2.2, at 0.01 level 3.11. Friends, our T value is 2.15. That is smaller than 2.2. That is required T table value at 0.05 level. So hypothesis is not rejected. And it is less than 3.11 also. It is required value at 0.05 level according to T table. So our calculated value 2.1534 is less than both the values. So hypothesis will not be rejected because T calculated is smaller than T table value at 0.05 level and also at 3.11 level. So in this way, with the help of probability and with the help of T value, we can check the hypothesis. But in our research report, sometimes we have to put all the values like N and mean and SD and mean difference. So these values are given here. These all the values are calculated with the help of Excel. How it is calculated, that we have seen in the previous video, so it is not discussed here. And as this is correlated means, we have to find R also, correlation coefficient, by Carl Pearson's method, and it is also calculated by using Excel, and the value of R is 0.273. Friends, in this way, in this video we have seen how hypothesis is checked when two correlated means are given. Now in next video we'll discuss more about t-test. Till then, goodbye. Thank you.